enough because you see this high signal area in there. That's the medial collateral ligament, and you see that high signal area with disruption of the ligaments over here. Next thing that we can look at is the subluxation or dislocation of tendons. These predominantly occur in the wrist, in the extensor carpi ulnaris, which can dislocate medially, in the shoulder, the long head of the biceps, which can dislocate medially again. In the ankle, the peroneal tendon can dislocate medially or laterally, and the posterior tibial tendon, which can dislocate medially and anteriorly. And I have some pictures of the biceps tendon. That is the bicipital groove where the tendon should be sitting. It's empty over here. That's the fluid in that, and that's the tendon subluxated almost within the joint near the glenoid cavity. Again, dark structure, not enough water to generate signal. There's another one. The bicipital groove is filled with fluid, no tendon in there. That's the tendon sitting right there outside the cipitula. And that's another view in which you can see the tendon subluxating right there medially. Ligament injury, we're talking of the ACLs and the PCLs. That's the ACL. Again, it shouldn't have so much signal in it. It should be quite dark, but it's not dark. It's very swollen, and there is this in which there are no non-ionizing radiations. What we use is a magnetic gradient. And just to give you an idea of what sort of magnetic field we are using 1.5 Tesla. 1 Tesla is 10,000 Gauss, and the Earth's magnetic field is 0.5 Gauss. So you can imagine the amount of magnetic field that we are using here. The other thing that we use in this examination is radio frequency, the same radio frequency that you use to tune in into a radio. And of course, we use these signals to generate images. It uses the free protons in the body. MRI physics is really the most complicated physics that I've had to negotiate during my career. Anyhow, it uses the free protons in the body, which are mainly come from the hydrogen atoms in water. Signal here, and you can see that that's what the normal signal should be, but this is completely ruptured here. There is a discontinuation right there. That's a posterior cruciate ligament. Again, it's very bulky, it's gray. The signal is almost like that of the muscle, which is not right. That should be much darker. And there you see a very high signal within this PCL, which means that this is torn. On the axis, so that's the PCL, and you see that high signal area within it. That's a partial rupture of the PCL. And there, that's a chronic this thing, and you can see that the PCL is very lax. Ligament injuries. You see again a medial collateral ligament, and that's again another medial collateral ligament which is bulky and gray over here, and there is discontinuation, and that's a tear there. Coming to the cartilage defects. Now just one little thing I want to tell you over here. You see this is bone. Now why is it so black? It's black because we suppress the bone marrow. We've suppressed the fat in the bone marrow. At this stage, most of the signal in the marrow is from the fat. And when you apply a certain sequence, which we call the stir sequence, and there are other ways of doing it, the bone becomes completely black. And we do that to get this signal from the cartilage to stand out. And that's what a normal cartilage should look like. This bright area, which is very nice and concentric, and there are no defects in there. But if you look over here, in this same thing, there is the cartilage there, and you see a defect there. So these cartilage defects can again be picked up very beautifully on some of the MR images. And there is grading of cartilage. You will know that better than me. There's grade 1 in which there's superficial, grade 2 in which it's half or greater, 3 when it is almost down to the bone, and grade 4 when the bone is involved. And there is a defect which is going right up to the bone. That's a grade 4 image. And there's another one over here which is a much smaller defect. Effusions. You all are used to looking at effusions on the x-rays, where you can see an anterior fat pad which is pushed forward called the Sale sign, and the posterior fat pad has become visible here. This is because of the effusion lying over here. And on the MR, that right thing is the effusion around the